This is class 10th NCERT Maths book, exercise 1.3, question number 1. Question is, prove that root 5 is an irrational number. Now, for proving this, root 5 is an irrational number, we can apply contradictory method. Contradictory method is, whatever is to be proved, just contradictory to that is assumed. Like here we assume that root 5 is a rational number. And then logically we will prove that our assumption is wrong. Using some logics and some properties, we prove that our assumption is wrong. So that is contradictory method. And before proving this, we are using one more theorem here, that is that proof is based on fundamental theorem of arithmetic. What is that theorem? I'll explain it later. That theorem is, let P be a prime number if P divides a square. If P is a prime number and if P divides a square, then P divides A, where A is a positive integer. This will be explained later when those steps we come across. So let us start from the first step. Let us assume to the contrary that root 5 is a rational number. So if this is a rational number we have assumed, that means root 5 can be written as P by Q, because this is the form of P by Q, where P and Q belong to the set of integers, but Q should not be equal to 0. This is the definition of rational number. Means we supposed it as a rational number, so this can be written as, represented as P by Q, where P and Q belong to the set of integers, but Q is not equal to 0. Now after representing in the form of P by Q, we cancel out some common factors if you have, and we are writing in the same rational expression in the least form. Suppose its least form is A upon B. Least form means there are no common factors between A and B except 1. 1 is the only common factor. So such numbers A and B in this case are called co-primes. A and B are co-primes. Means there is no common factor between A and B. We have cancelled the common factors. This is our, this we have taken as we have supposed. Root 5 is equal to A by B. A and B are co-primes. Now after this what we are going to do? We are trying to show, logically we will show that whatever we have supposed, that there are no common factors between A and B except 1, that is wrong statement. We are going to get some common factors between A and B. That is what we are going to show. How we are going to show that we can see? First we cross multiply this. So we got A is equal to root 5 into B. Now on squaring, we are squaring them. Then we get A square equals to 5 into B square. So now we are applying that theorem. This means this is dividend equals to divisor into quotient plus remainder. Remainder is 0. That means we are applying here a theorem based on fundamental theorem of arithmetic. That is, here you can say 5 divides A square. That is the theorem we are applying, that if 5 divides A square, then 5 divides A. 5 divides A square means this A square is exactly divisible by 5. How do we know that it is exactly divisible? Because here the remainder is 0. There is nothing written over here. That means remainder is 0. So we can say that 5 divides A square. 5 divides A square means that A square is exactly divisible by 5. That means 5 is a factor of A square. In any way you can write it. Therefore 5 divides A. This is a theorem. Here theorem you can write that if P divides A square, P being prime number, if P divides A square, then P divides A. A is positive integer. That's what we have applied here. So with the help of this we got 5 divides A. A is exactly divisible by 5. Now this is the first equation. 5 divides A we have taken. That means it can be written as A equals to 5 into some quotient. Let us take it as C. Plus remainder should be 0. This statement we have written in expression form. 5 divides A means A is exactly divisible by 5. That means A is dividend, 5 is divisor. So we can get any quotient. That quotient we have represented as C and remainder is 0. So we got A is equal to 5 into C. A is equal to 5C. Now this also you square. On squaring we get A square is equal to 25 C square. Now this is the second one. Now by equation 1 we got A square is equal to 5 into B square. So that you apply here. A square you write 5B square is equal to 25 C square. Now cancel out common factor. We got B square is equal to 5C square. That means once again you can say that B square is equal to 5 multiplied by C square. That means remainder 0. That means 5 divides B square. That is 5 divides B square. Therefore you can say 5 divides B. Now let us concentrate on these two steps. 5 divides A and 5 divides B. These two we have proved. Whereas in the beginning we had supposed that between A and B there are no common factors. But after these steps we are saying that A has a factor 5 and B is also having a factor 5, same factor. That means this goes contradictory to this statement. You can say this root 5 is equal to A upon B. You can call it as statement number A. So with the help of these two we have proved that A and B have some common factors. So you can write here, but initially we supposed that A and B have no common factors. So this contradiction arises because of our wrong assumption. Therefore, we can say that our assumption is wrong. That means we have to correct our assumption. Our assumption was that root 5 is a rational number. So let us correct this assumption. So we can write here, therefore root 5 is an irrational number. That's all.